Hi everyone. Today we are starting a new unit. The new unit is called Probability. Today we will focus our attention on the counting principle, permutations, and combinations. So first, let's explore different types of possibilities through an example. So, example number 1. Mike goes to the local deli and sees the following breakfast specials. He sees 3 different types of sandwiches, 4 different types of sides, and 2 different juices. Part A is asking us to draw a tree diagram to determine how many breakfast specials he can order. So if you feel that you can fit your tree diagram vertically over here in this space, if you write small, then that's fine. But I write a little bit large, so I'm going to put mine here. So we're going to first start with the types of sandwiches. So he has egg and ham. So I'm going to label that as just ham. Then we have egg and bacon. So I'll label that with bacon. And then egg and cheese. So I'll just label that with cheese. Now what could he get? Say he decided to choose ham. He could get eggs with ham and a side of potatoes, or eggs and ham with a side of apples, eggs and ham with a side of fruit, eggs and ham with a side of donut. So those are all possibilities. So for each ham sandwich choice, he's going to have 4 possible sides. So 1, 2, 3, 4. P for potatoes, A for apple, fruit cup, and donut. Do you think that he would have the same 4 sides if he had chosen egg and bacon? Yeah. So let's go ahead, do the same thing. And also, if he ordered cheese and eggs, it would be the same thing. He could get a potato, an apple, fruit cup, or donut. Okay, so say he decides to do ham and potatoes. What are his options for a juice? You should be saying orange and apple. So for each one of these, we're going to need 2 branches, because with the potatoes, he can get either apple juice or orange juice. With the apple side, he can get orange juice or apple juice. With the fruit cup, he can get apples or orange juice. And with the donut, he can get apples or orange juice. Same thing for the bacon. And same thing for the cheese. So let's go ahead, label all this. Okay. So the question is asking to determine how many different breakfast specials can he actually order. So we can get ham, potatoes, orange juice, ham, potatoes, apple juice, ham, side of apples, orange juice, ham, side of apples, and apple juice. So you see how each one of these 2 branches on the bottom represents all the possible choices. So he's got 2 here, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So this tells us that there are 24 possibilities. So he can get 24 possibilities. Okay, there's got to be an easier way, because what if he was there and there were 10 sandwich choices, 15 different sides, and 4 different juices? Life is going to be a lot harder. So they have this shortcut, and the shortcut is called the fundamental counting principle. So let's read that. It says, if one event has m possibilities of occurring, and another event has n possibilities of occurring, then the 2 events together have m times n possibilities of occurring together. So this pattern will apply for any number of events. Doesn't necessarily have to just be one event m and another event n. I could have m, n, and another one, just like the example above. I've got 3 different events, if you would, going on. I have sandwich, sides, and juice. So what would I do with the sandwiches, possibilities, the sides, and the juices? Well, the counting principle tells us that we would multiply. So let's use that. So let's look over here. The number of possible sandwich choices are 3. The number of possible side choices is 4, and the number of possible juices is 2. So if we multiply 3 times 4 times 2, we will get 24. So this 24 is the shortcut way of getting the possible combinations that he could get. He could get whatever sandwich he wants. Now how about part C? What if I say use the counting principle to determine how many different specials he can order without meat? So let's go back. The only possibilities without meat here are egg and cheese. This has ham, that has bacon, so that's meat. None of the sides have meat in it, and none of the juices have meat in it. So what that does is that narrows down my number of possible sandwich choices to 1. He can only get egg and cheese. He can't get bacon or ham. The number of possible side choices didn't change, that's 2, nor did the number of possible juices, so that would be 2. So what we're going to do is we are going to multiply 1 times 4 times 2, and we get 8. So 8 is the total number of possibilities that he can order without meat. And that's it. That's the counting principle. Let's see how it works with another type of example. Example 2. How many unique 4-letter arrangements can be made using the letters in the word rhombus if the word must start and end with a different consonant and 2 non-repeating vowels in the middle? Okay, so we need 4 spaces. 1, 2, 3, 4. And we're going to eventually multiply them together because that's what the counting principle says. So what is the first event? The first event would be the beginning. It said the word must start with a different consonant. Well, how many consonants are available? So let's see. Number of possible consonants. So let's see. We've got R, that's 1. H, that's 2. M, 3. B, 4. And S, 5. So there are 5 possible consonants that are available for that first starting spot. And it also says that we have to end with a consonant. So we'll come back to that later. But what does it say about the middle? It says the middle has 2 non-repeating vowels. Well, what are the number of possible vowels that we have to choose from? So that's going to go in the second spot. Well, we've got the O and the U. Those are the only 2 vowels that we have, so there are 2 possible vowels. Now it says non-repeating vowels. See over here, non-repeating. So what that means is whatever vowel is here cannot be here. So how many, what is the number of possible vowels for the second spot of vowels? So really the third, but how many are available now for here? You should be saying 1 because I've already used 1 here. So there were 2, now there's 1. And last but not least, it said it has to end with a vowel. A consonant. So number of possible consonants. So there are 5 to begin with, but isn't 1 already used here? So it must start and end with a different consonant. So 1 is already being used, so how many are going to be here? You should be telling me 4. So if we multiply 5, 2, 1, and 4, we will get the number of possibilities that we can arrange these letters, and that would be 40. So there are 40 possible arrangements. Let this sink in a little bit. If you're still confused, we'll definitely practice more of this tomorrow. Okay, let's try the next page. So the next page, we're going to go into what we call a permutation. So a permutation is the choice of choosing R things from a set of N things without replacement and where order matters. So let's underline this, star this, circle it, do whatever you got to do, but you have to know that permutation is where order matters. So a little note before we do examples. Has anyone ever seen this exclamation point before? This N exclamation point is read N factorial. So what that means, factorial, means we're going to take whatever number is given, which is 4, and multiply all the way down to 1. So this means 4 times 3 times 2 times 1. If you wanted to multiply that, you'd get what? 4 times 3 is 12. 12 times 2 is 24. So that would be 4 factorial. What if I wanted to do 17 factorial? That's obnoxious, but we could still do it. It would be 17 times 16 times 15 all the way down to times 1. Now you wish that you had a calculator to help you with that, and you do. Let's explore the calculator. So let's go to the last page of the packet. It looks like this, and we're going to use the calculator to find factorials. So let's go down to the bottom where it says factorial, so right about here. So we want to example, compute 6 factorial. So what you're going to do first is clear your calculator screen. Make sure you have a clear screen. Enter your first value. So go ahead, enter 6. All right, we're going to hit the math key. We're going to arrow right until you see PRB. And this is the screen that you're going to see in the PRB once you go all the way over. PRB, and you're going to hit 4 where it says factorial and press enter. So on your screen you should be seeing 6 factorial, which is 720. Okay, so while we're here, let's look how to input permutations and combinations. I didn't discuss what combinations are yet, but let's figure out how to do a combination. So say I wanted to, a permutation. Say I wanted to do 6p3. You would enter your first value, so clear your screen and enter 6. Then hit the math key and arrow over to the right to PRB. So again, you're going to look at this screen up here, but now you're going to hit 2 for NPR. And then go ahead and put in the 3 because we want to do 6p3. So you're going to see 6 NPR 3. That means 6p3, and that would be 120. If I wanted to do a combination, I would simply just look in the same spot where I was, hit math, PRB, and then hit 3. So let's go back to examples. Example number 1. In how many ways can 5 students be chosen for president, vice president, and secretary for the school council? So you should be asking yourself one question. Does the order matter? And the answer is yes. So we are going to do 5, because we have 5 students, and we are going to pick groups of 3. So 5p3, 5 represents the total number of students that we have. 3 represents the groups that we want to make out of. So if it's easier to think of permutations as the counting principle, you can do that. We have 5 students and we want groups of 3. So how many students are available to be the president? You should tell me that there are 5. Once I pick the president, how many are available to be the vice president? 4. And once I pick a president and a vice president, how many are available to be the secretary? You should be saying 3. So this would be actually what 5p3 equals. So let's go ahead, put 5p3 into the calculator. So again, you're going to hit 5, math, scroll over to PRB, and find the NPR button, hit enter, and then hit 3. So 5p3, you should be getting the result when you do 5 times 4 times 3. So 5 times 4 is 20, 20 times 3 is 60. So there are 60 different ways that I could pick a president, vice president, and secretary from a group of 5. Okay, let's try example number 2. How many 3-letter words can be made by using the letters in the word think? Well, first off, how many letters are in the word think? T-H-I-N-K. So 5. So I have 5 letters, and I want to pick different groups of 3. So that's why I do 5 is my total. There are 5 letters in the word think. There are 3 groups that I want to make, or 3-letter words. So 5p3, again, if you just look from example number 1, is 60. The hardest part about these questions are going to be to determine whether you're going to use a permutation or a combination, which we're going to talk about in a minute. So let's do last example here. Example number 3. In how many ways can 4 trophies be arranged on a shelf? Okay, the order really does matter here. How many trophies are available for the first spot on the shelf? You're going to tell me 4. Once that first trophy is placed, how many possibilities are there for the second spot on the shelf? You're going to tell me 3. And then after 2 trophies have been placed, how many are available for the third spot? And then how many are available for the 4th and last spot? You should be telling me 1. So if you multiply 4 times 3 times 2 times 1, you should get 24. And that should be familiar to you. Wasn't that our answer up here for 4 factorial? 4 factorial we said was equal to 24. So this is an example where I could use permutations, I could use the counting principle, which is here, or I could just know that it's 4 factorial. So this 4 factorial is 24. I could have also done, I have 4 trophies and I want to pick different groups of 4. So 4p4 is equal to 4 times 3 times 2 times 1 right here, which is also equal to 4 factorial. So just a little trick for that one. If you're confused with that, don't stress. We'll go over it tomorrow. How about repeating permutations? How many unique word arrangements can be made using the letters in the words, let's say cranberry? There are 9 letters in the word cranberry, and I want to know how many different ways can I arrange them. If all of the words were different, or all of the letters, were different, we could do 9 factorial. But since there's a repeat, what do I mean by repeat? Look at this. There's 2 R's. So since there are 2 R's, we can't have the same thing, so we have to divide out by 2 factorial. And that 2 factorial is for the repeating R's. There are 2 R's. So if the word, say, was think, like we did before, T-H-I-N-K, none of the letters repeat. So if I want to figure out how many 5-letter arrangements, because there are 1, 2, 3, 4, 5, I would just do 5 factorial. And I wouldn't have to divide out by anything. But I want to know, if I have repeats, what do I do? So we take the 9 factorial and divide out the repeats. So in the calculator, type in 9 factorial divided by 2 factorial. Remember, the factorial button is in that probability place. And once you do that, your answer should be 60,480. So there are 60,480 different possibilities with the letters of the word cranberry. How about Tennessee? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial would be great if there were no repeats. But since there are, we need to divide by the number of repeats. So do you see how there are 2 n's? We could divide this by 2 factorial for the n's. And how many e's are there? I see 1, 2, 3, 4. 4 factorial for the e's. And I see 2 s's. So 2 factorial for the s's. Now, what's most important about this whole thing is that you cannot put it into the calculator in one step unless you put parentheses around the denominator. I'll talk more about that in class tomorrow, so why don't you see if you can actually get a number out of the calculator for this. And that number will be 1,260. So try typing it into the calculator just the way you see it. 9 factorial divided by parenthesis 2 factorial, 4 factorial, 2 factorial, close. Pause the video if you need to, and then when you're ready, hit resume. Okay, next and last page. A combination. What is it? A combination is a choice of R things from a set of N things without replacement and where order does not matter. Underline, circle it, do whatever you need to do, but combination means order doesn't matter. This is a formula. Do you ever need to know it? No. You just need to know how to put this piece into the calculator. So, let's go by example. In how many ways can 5 students be put into groups of 3 for an activity? How is this different than the problem on the first page? I still had 5 students, but I had 3 specific, I guess if you want to call them, roles for them. I had a president, a vice president, and a secretary. Here, do I have any distinction? Do I have any roles? No. So what I'm going to do now is just I have 5 students. Now I want to choose, C for choose, groups of 3. So this is my total number of people, and I want to choose groups of 3. So put this into the calculator. Type in 5 first. Go to the math probability section, get the C, and then type in 3, and then enter. If you do that, you should get 10. So there's a smaller number of ways that we could do that. Okay, next. 2. A coach must choose 5 starters from a team of 12. So 12 is my total. So I have 12 students, and I want to choose groups of 5. Doesn't matter where the starters are going. Say it were a baseball game and they wanted to say this person was going to go to first base, that person was going to go to second base. That is where they're giving them a specific role, so that's where permutation would matter. But since I'm just saying I want to randomly pick these 5 people, I'm going to have 12 people and I want to choose groups of 5. So 12 is my total. And I want a group of 5. So go ahead, Pause the video, plug that into the calculator. You should get 792. All right, last but not least, example number 3. There are 14 juniors and 23 seniors in the math club. The club is to send 4 representatives to the state competition. How many different ways are there to select a group of 4 students to attend the conference? Does it specify what types of students they want? Does it say they want only juniors to go or they only want seniors to go? No. So what we really should do is add up the total number of students that we have to choose from. If you do that, you get 37. So 37 is the total number of students. So I have 37 people, and I want to choose groups of what? I want to choose groups of 4. So put that into the calculator, and you should get 66,045. So there are 66,045 different ways that I can make groups of 4 out of 37 people. And notice on all 3 of these examples, I'm not giving anybody any distinct roles or places they need to be at. I'm just saying, how can I choose them? So that's really the main difference between combination and permutation. Just as a recap, permutation order matters, combination order does not matter. Okay, let this sink in, and we'll see you tomorrow. Write down any questions that you might have, and I'll answer them tomorrow.